As you read from the title, in this video we're going to learn how to detect faces in an image using OpenCV. So this is going to be a really basic intro to computer vision using OpenCV with Python. So let's get started. Now the first thing we obviously need to do is install OpenCV. So if you haven't already, open up the OpenCV installation page and copy the command, or just type it into your terminal. So I'm going to go ahead and copy it and open up the terminal here. Let's make this a bit bigger. Let's paste it in and hit enter. And it's going to tell me that the requirement is already satisfied because I've already installed the module on my computer. But if you haven't installed it, then everything should go fine. But if things don't work, then I recommend just going back to Python 3.9. I tried it earlier with Python 3.10 and it didn't work. So I rolled back to Python 3.9 and it worked again. So back here in Visual Studio Code, I've created a new script called main.py in my project folder, and I'm going to start out by importing OpenCV. So to do that, we're going to say import cv2. So the first thing we need to do to get started with detecting faces in Python is create a cascade classifier. Basically what a cascade classifier is an object in cv2 that allows us to detect things in an image. So the way it works is it takes the image and it splits it up into a bunch of smaller images and it goes through each of them. It uses an algorithm to check if one of them is a face, and if it is, then it goes in depth on that part of the image and it keeps checking until it's certain that it's a face. So that was just a super basic rundown of how it works. You can read more at the link in the description. So I've provided this link in the description where you can read more about how cascades work in cv2. They're basically the most important object in cv2 for detecting things. But for now, let's just go back to our script and let's create a cascade classifier. So down here, we're going to create a cascade classifier and we'll call it face cascade. And it'll be equal to cv2.cascade classifier. And we're going to have to pass in an XML file with a bunch of data on it. And we're going to need to download this XML file from GitHub. So once again, I've provided a link in the description to this XML file on GitHub that basically contains all the data we need for our cascade. As you can see, it's a really long XML file and it has a bunch of data that tells our cascade basically what to do. So you want to go ahead and save this into your project. So mine is facial detection with Python, and as you can see, I've already saved it here. And you have to make sure that it's in the same folder as your main.py script. If it isn't, then you're going to have to either change it or reference it inside of your script. So since I already have it, I'm going to press cancel. So if I open up my folder here, I'll find my XML file, and I'm going to go ahead and click rename so I can copy this and paste it in right here. And we're going to add a .xml. And now we've created our face cascade. The next thing we're going to need to do is read our image. So down here, we'll create a new variable called image, and it's going to be equal to cv2.imread. And the file name is going to be image1.jpg or whatever you named your image. So as you can see here in the folder, we have a nice picture of The Rock, who released a banger song, by the way, a couple days ago. Link is in the description, obviously. So yeah, we have this picture of The Rock, who is now a very talented rapper, and we've referenced it in our image variable. So as you can see, this image that we have here is in color, and cv2 doesn't process images in color. It processes them in black and white. So we're gonna have to convert it to black and white. So we'll create a new variable called gray image, and it's gonna be equal to cv2.cvtcolor. We're going to pass in the source, which is going to be our image, and we're going to pass in cv2.color_bgr to gray. And this is going to convert our BGR image, which stands for blue, green, red. Normally it would be RGB, but cv2 does it backwards. It's going to convert our BGR image to a grayscale image. Next, we're going to detect all of the faces in our image. So we're going to create a new variable called faces, and it's going to be equal to facecascade.detect multiscale. And this is arguably the most important line of code in our entire script. It's basically the thing that detects all of the faces in our image, and we're going to have to pass in some parameters to this method. The first is going to be the image, which is the gray image. And the other two are more specific parameters that can change depending on what image you're using. The first one is the amount that CV2 scales down every time. And that means that when CV2 detects a part of the image that is a face, it scales down by 0.1% or 10%. So this last parameter is called minimum neighbors, and it's basically saying how many neighbors a rectangle that we know is a face must have for it still to be considered a face. So if we had a block that we thought was a face and we needed 3 neighbors around it to also be faces, then CV2 would check around them, and if 3 neighbors are also faces, then it retains its title as a face. And what you need to know is that the higher this number, the less false positives you're going to get, but if you make the number too high, you're also going to rule out the true positives. So you have to be careful with this. If you make it too high, you won't get as many faces as you would like, and if you make it too low, you're going to get too many faces. For this image, I found that 10 was a good number, but it can change depending on your image. And also, this parameter can also change depending on your image. So you're going to have to tweak these around to get the perfect result. And we're almost done. We just need to draw the rectangles on the faces and then put the image on our screen. So we're going to iterate through 4 coordinates in our image and draw a rectangle on the ones that are faces. So for x, y, width, and height in faces, we're going to say cv2.rectangle. We're going to draw it on our image. The first point is going to be at x and y, and the second point is going to be at x plus width and x plus height. We're also going to need to pass in the color that we want our rectangle to be. I'm going to say we want it to be yellow, so we're going to pass in 0, 255, 255. So this means that the blue value will be 0, the green value will be 255, and the red value will also be 255, because we have to remember that the colors are inverted in CV2. And last but not least, we're going to need to put in the width of our rectangle, and I'm going to say that's going to be something like 10, but you can change this if you want. Now we need to just show this on our screen, so we're going to say cv2.imshow. We're going to pass in the name of the window, so I'm going to say detected faces, and the image that we want, so that's going to be image. And the final line of code is just going to wait for us to press a key before exiting the program. So cv2.waitKey. Now, if we've done everything correctly, when we run this, we should get a yellow rectangle around the rock's face. So here we go. We do get a yellow rectangle around his face. As you can see, the best wrapper in the world now has a detected face, detected by Python. You can customize a ton of variables in this script, like the color of the rectangle, the width of it, and the 2 parameters, which are the scale factor and the minimum neighbors. I hope you enjoyed this tutorial and I hope you learned something from it. I'm sorry I haven't posted in a while, just been busy with school. I'm definitely going to post more frequently now. Thank you so much for sticking till the end, and I'll see you in the next video.